Now, balancing can be done oversampling, undersampling, etc. What does oversampling and undersampling mean? Highly asked question in interviews. You can see clear difference between the median total day minutes talk by people who are not churning versus who are. We can even create new columns. This entire data went through this pipeline that firstly it was encoded. What all was encoded? These columns. Then this column was transformed. These columns were dropped. These columns were scaled based on the learning from the training data. So once we have trained it, we don't need to train them again and again, right? So model is saying to churn and how many of them actually churn. That is going to say tell you how precise your model is. Scaling before splitting violates the principle by allowing the model to see some information of the test set indirectly, right? That is why you use dot transform on xtest and fit transform on train. You can develop an ML pipeline and it will pass the news dataset to through that pipeline and finally predict. But if you come from certain state, your possibility of churning is very high as compared to others. So in these kind of cases, doing target encoding is a very good way. You have various models and various matrices as columns: accuracy, precision, recall, F1 score, and ROC AUC. This is what a confusion matrix looks like. And let me tell you how to read this. So this is the pipeline that has been created. You have first one as encoder, lock transform, drop columns, then you scale the robust scalar and remainder columns are passed through. So hey guys, welcome back to the channel and welcome to the second episode of our data science project series, where we take a dataset asked in real assessments at various companies and develop end-to-end project using that. Today, we are taking the dataset asked in data science interview take-home assignment part at Sony Research. In this assignment, we are given a sample dataset of telecom companies' customers, what all various columns mean, and what we basically need to do that is develop a model to predict customer churn. Okay, so what are we going to cover in this video? In short, end to end in complete detail, but let me give you a very brief overview. So once we load the dataset, we will start with performing inspection on the dataset to get a feel of how our data looks like. Then we will be moving on to the pre-processing part and see why it is required. Then, after that, we will be moving on to exploratory data analysis or EDA, which is one of the most important aspect of any ML project. People often ignore it and directly jump to training models, but I can tell you with all my years of experience in this field, EDA helps you form stories that your stakeholders want to listen to. Things you can check, but you need to be curious enough. Then, moving further from EDA, we will be learning about feature engineering and its various aspects. Let me ask you a question. How many of you perform all feature engineering steps and then perform train test split? If you are thinking, okay, that is how it should be, right? I'll share with you an example of why this violates this principle of your ML model shouldn't see any test data because it is going to overfit. So once we understand this, then we will be moving on to the feature selection part. Do you remember the iconic saying in machine learning, curse of dimensionality? We will be seeing that and why this step is important. In real world, you will find that not every time a dataset is completely balanced. One group is often present more than the other one. So we will learn about how to balance class and why if you do not do this, your model can become biased. Okay, already we covered a lot, right? Finally, when we are done with all that, we will be training multiple classifiers and see how they perform on training set, validation set, and test set. And you might have heard one of the most asked interview question in data science is, can you explain the difference between accuracy, precision, recall, F1 score, ROC, AUC, and when they should be used? We are going to learn this and you will never forget this again. We are going to learn them by seeing them in action. Not only that, We will be refining our model through hyperparameter tuning to make them even better. What is the purpose of doing all this? It is to make predictions on new data. And you might have heard about developing machine learning pipelines and might have often wondered, what do they mean by an ML pipeline? How can we do that? We are going to learn that as well. So, you see, too much to cover and time is of an essence. Stay tuned and I guarantee that after this video, you will be able to take any dataset and go start to finish on your own. So yeah, let's start. So the first step of any machine learning model is you need to have certain libraries, right? Now here you see a ton of these things that I have been imported, like if you see classifiers, column transformers, pipelines, etc. But remember that it is not that I have done this on the very first go. So when you will start as simple as import numpy as an np, pandas at pd, maybe since you are going to, make plots, matplotlib and seaborn, etc. Everything else is added step by step. So once we have the starting libraries, the first thing that we should do is we should load the dataset. I have already, uploaded the dataset in Everyday Data Science GitHub repository. So here, I will share this link in the description box below. So here, if you go to the Sony Research data part, right, you are going to see this data science challenge. And how did I get this link? If you click this, you are going to see a sample version of this data. What you need to do is you need to click raw, and then it is going to take you to this and switch to my Google Colab notebook. And we learned about why to use Google Colab, etc. in my previous one, right? If you want, you can watch. The link will be in the description box below. Okay, so this is the URL where we are going to fetch the data from, and then we simply read CSV using this URL. And we also performed a copy of this data frame. It will be useful, and I will be explaining you why in a bit. And then if I go ahead and run this, so this is how the data looks like. You have various columns, state, account length, area code, phone number, etc. Right? So we have all these columns. And then finally, we have the target variable, which is churn, that after all these features, whether the customer churned, false means it is not churn, and true means churn. Now, what is basically churn, right? What is the definition of churn? Churn is, just think about it. Let's take example that you are subscribed to Netflix, right? Now you watched Netflix for a couple of months and then you are like, okay, I don't find interesting. The genre of movies that I want is usually not uploaded, and or the type of movies they upload is subpar. So let me just cancel my subscription. So that is what churn is. That for any subscription based business or even for non-subscription based business, you can define churn, but it is usually canceling your subscription or moving away from a certain thing, right? So that is what churn is. Okay, once we see this data frame, then what should we do is we should learn, okay, what all these different columns mean. So state columns is state where a customer is coming from. Account length is the number of days a customer has been using services. Area code is area where a customer comes from, phone number of a customer, etc., etc. If you want, you can pause it and read this as well. Similarly, you have customer service calls, like the total number of customer service calls made by a customer and whether a customer churned or not. Okay, once we are aware of, okay, we have loaded the data set and then we have definition of all the columns, then let's start with the initial inspection part. So now in the initial inspection part, what we are trying to do, what is the purpose of this step? We saw these are the names of various columns, but it is difficult to count those, right? Okay, what are the number of rows in it? So we try to get the shape, we try to get the data types of each of these columns. We see whether there are missing values, duplicate values, what are the summary statistics, like what is the mean value, what's the minimum, maximum, etc., just to get a feel of the data set. Then we also look at whether there are outliers or not. And then finally, the class balance, right? Because it is very important. Otherwise, if you don't check for class balance, maybe 95% of your data is of one category and you need to predict the other one. So you are going to have bias towards the 95% category, right? So we do not need that. So let's start and check the shape of this data frame. So if I run this, it is going to show me that, okay, there are 3,333 rows and 21 columns. What does this mean? 21 columns means 20 features and one column is churn, which we need to predict. Now, let's look at the data types. So basically, of all these 21 columns, what is the data type? And this can also tell you how many total null values or missing values are there, right? So we had total 3333 rows. And if you see, all of them are not null. So we can just by looking here, we can see that none of the rows are missing, but we will be checking that and try to see another way of checking that. But our purpose in this step is try to check the data type. So if you look at it, it seems okay in most of the cases that churn is true or false. So it is Boolean value. State is obviously it could be any of the 50, 51 states. So it's object because it's string, phone number, international plan being yes or no, voicemail plan yes or no. So these are objects. Okay. However, if you look at the area code, it says integer 64. Let me just, scroll back and let's look at this data frame and see the area code. So yes, it does look like this, but just think about it. You need, like, this question should come to your mind that, okay, 415 area code. If you take the average of, let's say, 415 and 408, that means something to you? No, right? Because it is the area code. It would be 415 for, let's say, New York, 212 for whatever, right? New Jersey, etc. So it does not make sense. So yes, one of the thing that we established is that, hey, the data type of area code might be wrong. Okay. Let's move on. So as we already say, but this is a way of checking whether there are null values in any of the column. And if I run this, it is going to show me that yes, 000 in everyone. So there is no missing value. If there are missing values, what you need to do? You need to then apply various methods of imputing. You can do mean imputation, frequency imputation, target imputation, etc. Then we also look at if there are duplicate values. Let's do that. So there are no duplicate rows. Okay, we have established no missing values, no duplicate values. Let's look at the summary statistics. Now, mostly the variables are of two types, numerical variables and categorical variables. In numerical variables, if you do the describe, what you are going to see is for every of the numerical variable, and you see area code, since right now it is integer, it is going to show you a area code of 437.18. Does that make sense? No. This also confirms our hypothesis that the data type of area code should be a string or an object, not an integer. But yeah, for everything else, what you see is you have the average, right? Average account length. So that means that on average, if this is months, right? So this is something, this is a subscription of something which usually people keep for longer and longer periods of month. What's the minimum account length, maximum account length, what's the median account length, etc. Right? So you get a good feel of what is the minimum, max, and the ranges of each of these numerical variables. Now for categorical variables, what you need to see is how many various types of categories are there, right? So for these are the four ones which are categorical. So how many unique kind of values? So right, 50 states plus one DC, so 51 different. Then every phone number is different. That means it belongs to a different customer. International plan, that is yes or no. Similarly, voicemail plan. Here you can also see that out of 3333, 3010 are no. That means you start getting a feel that yes, in this data, most of the people do not have international plan and this is not yet global, or they are planning to expand, right? So you see how you should start thinking about data as you are doing this, that you should start forming hypotheses and try to just imagine what this data could tell us. Whether you are right or wrong, you can check in subsequent steps, but you should start forming a story. Okay, once we have this, then let's look at outliers also. And this is a function that I have written. You can copy this, like, because this is like a very standard way of calculating outliers. What we are basically doing is we are doing the interquartile range. Interquartile range is quantile 1, that is 0 to 25%, and quantile 3 is 75 to 100%. So that medium range, right? So 1.5 times of that medium range, if you are below that or above that, that means that you are an outlier, because most of the values usually lie in this part, right? So that is what this function is telling you. And then what we are basically doing is we are passing this function to the data frame that we have all the outliers, and then we are converting it into a data frame. Okay, let me run this and I will tell you why we need to look at outliers. So if we look at this, yes, there are good amount of outliers. Now, why do we have and why do we need to check for outliers? Okay, so you might have learned, and if you are new to this, just remember that there are a lot of machine learning algorithms which are based on distance. And if there are outliers, that means that if you do not look for these outliers or do not try to work on this, then those distance based, and what are examples of distance based? Logistic regression, k nearest neighbors, etc. Right? Because what is the philosophy of k nearest neighbors? You try to find out the nearest neighbor. What is nearest? That means the minimum distance, right? So you see, distance based, all the machine learning algorithms are going to fall trap to these outliers, and they will start becoming biased towards that. So either you deal with outliers, and let's say you do not want to deal with outliers, then you should use tree based models. For example, random forest, decision tree, XGBoost, light GBM, etc. Okay, once we have the outliers, we know that there are outliers. So we need to deal with them or we need to use tree-based models. Okay. Then finally, let's look at the class balance. So we have the churn that we need to predict, right? Ideal condition should be 50% people churned or left, 50% did not. And based on that, we will train the model and say that, okay, these people are predicted to churn, these are not. But obviously, if you look at this, what do we have here is we have false. That means 85.5% or 86% of the people do not churn, and only 14.5% have churn. That means this is how the class distribution looks like currently. This is highly imbalanced data. Why do we need to take care of this? Just think about it. Suppose in the current data, we have this much, right? So 85% do not churn and 14.5 will churn. If I just come to you, you give me any set of features, all I say is, no, it won't churn. What is the probability of me being right? 85.5%. Does that mean what I'm doing is right? No, because every time what I'm saying is no churn, no churn, no churn. And I have 85.5% of accuracy. So you see, in classification problems, accuracy is also not a good thing, right? So that is why, based on all these initial inspections, this is what we can summarize, that yes, there are 3,333 observations, there are no duplicates, all phone numbers are unique, 20 different features, and one target variable, that is churn, which we need to predict. There is no missing data. The data type of all features is correct, as we saw, except area code. Mean area code does not make. We talked about this. Most of the phone numbers belong to Wyoming state, right? I can just show you, scroll back and show you that yes, top is Wyoming, 106 phone numbers, right? Then if we go at what 90% of the people do not have international plan and 72% don't have voicemail plan. Majority of columns do have outliers, so we need to handle them, right? And then we have an imbalanced data set, that is 85% of the people did not churn while 14.5% did. And it is very important to deal with that. And yes, since this is a binary classification problem, churn or not churn, this is what you need to predict. And I just described why accuracy could not be a good measure of measuring your model performance, right? We will learn about this precision, recall, F1 score, ROC, AUC curve, etc., and why they become important in classification problems. And I have just written it down, like how can we deal with this class imbalance, oversampling, undersampling, etc., so that our model don't forget to learn about the minority class as well. Now, once we are done with initial inspection part, we got a feel that, okay, what does our data represent? What do columns mean? There are outliers, no missing values, etc. Then we will be moving on to data pre-processing. Now, since we already established that there are no missing data and there is no duplicate data, you don't need to do anything for them. If there was, you will have to do that in this step. Then let's move on to correcting the data type. So we already saw that the data type was integer, which was not correct. So we can just go ahead and change the data type as object or string, right? Let me run this. So you see, now you have area code as a categorical column, and we can see that 415 is the top one. That means 1655 out of 33. So almost 50% are 415 area code. So one area code dominates over the others. In the pre-processing step only, if there are some features that we strongly feel that they are not going to give us any information, we can even drop them. Why? What I'm going to do is, let's see whether the phone number can give us any information. So what I'm doing is I am replacing this, this dash sign, so that, and then I can count the length of the phone number. Why I'm doing this? What is my hypothesis behind that is, okay, maybe if you have different lengths of phone numbers, let's say 7 for landline, 10 for a mobile, etc., maybe that is an indicator of, for people who have landlines, the connectivity is not good, or people who have phone numbers or mobile phones, they travel to various places and connectivity is good, so maybe they won't churn. But for landlines, people will churn because the connectivity is not good. My hypothesis is that. But here, if I look at this, all the phone numbers have 7 digits. So essentially, phone number is not going to give me anything extra, that I cannot form any hypothesis, because every phone number is unique and the length is also same. So what we can do is just drop this. So we are going to drop the phone number from the columns, and if I go ahead and run this, we are not going to have phone number anymore. So right now, how many columns do we have? We had 21 to start with, we dropped phone number, and right now we have 20, 19 features and one target. Now, once we are done with the pre-processing steps, then let's move on to the exploratory data analysis part. In this part, which is very, very important, please pay attention to this and learn how to do this, because this is going to give you stories. This is going to give you the majority of hypotheses that you can make and build and start presenting. What are the three major things that we are going to do is, we are going to look at univariate analysis of numerical and categorical features. We are going to do multivariate analysis to learn correlations between these features and see how these features are related to the target variable churn. Do not worry if univariate and multivariate does not make any sense to you right now. I'm going to explain in detail. So let me just do df.info. Let's look at, okay, these are the 0 to 19, that is 20 columns as we were talking about. Okay, fine. Now let's look at the distribution of numerical features, and this is the code that I have written. Basically what it does is it creates subplots for each of the numerical features, right, so that they are adjacent to each other, and then it shows you the plot. Let me just run this and it is going to be clear. Now here, what do we have here? Firstly, what are these kind of graphs called? These are violin plots. What is the advantage of violin plots rather than a box plot or a numeric distribution? Is basically, if you see that, let me just zoom in a bit, right? So if you see this, right, total evening calls, here you have a box plot inside, and then you have the distribution. So you can see the distribution as well as the box plot, as well as whether there are outliers or not in one single chart. Okay, so you have for every one of them, right? So you have for account length, number of voicemail messages, total day minutes, etc., etc., right? So you have for all the numeric features. Now, let me just zoom in again. So here for account length, what do you see? You see a normal distribution. For voicemail messages, what you see is most of the data is around this, right? So there are two different patches. One is around 0 and one is around 30. So a lot more data around 0 and very less around 30. So we need to keep that in mind. That means this is a bimodal distribution and it is not normal distribution. We need to make sure that we remember this. Similarly, if we look at total day minutes, etc., right? Let me just look at again and all this. Here, everything else looks fine except this total international, right? This one, total international count. It is a normal distribution, but it is right skewed because you have the long right tail, right? And then if I look at customer service call, it is mostly, so you see a lot of data is between 0 and 2, and then you have a long tail, right? So what do you see from this? That customer service call, total international calls, and number of voicemail messages are the features that are not normally distributed. Why do we need these data to be normally distributed? Because again, a lot of these machine learning models, for example, logistic regression, support vector machines, etc., assume that data is normally distributed for them to work. Even this step also tells you that, let's say you are going to do a hypothesis testing, you have a hypothesis and you want to do experiments, A/B testing, etc. This step tells you that if the distribution is not normal, do you need to use parametric test like t-test, z-test, etc., or you need to use non-parametric test, Whitney, Cox, etc. We will be covering that in detail in another video, but remember that, right? Why this is important to look at the distribution of the features. Okay, once we are clear with this, then captured here that these three features are not distributed normally. So what we can do is we can leave them as it is and then use only tree based models. The same thing that we saw in outliers part as well, you can apply transformation so that we are free to use most of the model. Let's go ahead with second step, and we will be doing this in the feature engineering step. Okay, now once we are done with the numerical features, then let's go with the distribution of categorical features, right? So need to run this same code, right? But here what we are doing is we are trying to plot the categorical features and see, okay, what's the distribution of various categories. So we see that there are three different categoricals: area code, international plan, and voicemail. And this is what we saw, right? 90% of them do not have international plan, 72% do not have voicemail plan, 50% of the data comes from area code 415. Let me just zoom in, right? So 50% comes from 415, and there are three different area codes. You also get aware of that there are only three area codes: 415, 510, and 408. 510, 408, more or less very equal, right? And then international plan, we have this distribution, and voicemail plan. Okay, once we have this, then what we need to do is we need to find the correlation and pair plot for numerical features. What does this basically tell you? You might have heard about one of the interview questions define multicollinearity, right? So that is the reason why we do this and check for this, because it is possible that out of the 19 or 20 features that we have currently, some of them are giving exactly the same thing, right? And they are correlated with each other. Just think about this. There is a column which has valued, let's say, 1, 2, 3, 4. Then there is another column which has twice of this. So 2, 4, 6, 8. Don't you think both of them are exactly, they are 100% correlated, right? One is twice the other. So if you take both of these columns, both of them are giving the same information. There is just second one is 2 times the first one, right? So identifying those kind of features is important. Again, curse of dimensionality, that if you have too many features, right, your data is going to overfit. Machine learning models should always learn general pattern, not specific pattern, because when you learn general pattern, then only you can predict on the unseen data in a better manner. You are not going to overfit your information, right? So that is why there are multiple ways of finding correlations: Spearman correlation, Pearson correlation, etc. We are going with the Pearson correlation matrix, and let's plot the Pearson correlation matrix between various numerical variables. So here you have the correlation matrix of various features. So you have all the features on the left as well as on the bottom. The way to read this is account length is 100 per 1. It's usually -1 to 1. -1 means negative correlated 100%, +1 means positive correlated 100%. Every column is correlated with itself 100%. To read this correlation matrix is account length and account length are correlated 100%. Number of voicemail messages and account length is correlated 0%. Total day minutes and account length is correlated 1%, and so on, right? So here you see, if you see darker color, that means they are highly correlated, and you see it's usually greener part is suggesting 0. What stands out for you? Ignore the diagonal, because all the diagonals are basically the same variable or feature correlated with them, right? So it is always going to be 1. These ones, right? So let's look at what all these features are. So here, if you look at total day charge and total day minutes are 100% correlated. Similarly, total day minutes and total day charge, right? So it is same thing. So total day charge and total day minutes are 100% correlated. Total evening charge and evening minutes are 100% correlated. Total night charge, night minutes 100% correlated. And total international charge and international minutes are 100% correlated. When we say correlated, it means that if we do a pair plot, what is pair plot? That every variable is plotted against another variable, right? And if we plot that, it is going to show a clear indication. Let me just plot you. It would be no very easy and intuitive to see. Okay, so if you see this, I know this is very small, but let me zoom in one of them. So we saw that total day charge and total day minutes are 100% correlated. So let me find total day charge here. So here, if you look at total day charge, and let's look at, this is a straight line, right? So that means if I see what is the variable down here, we have total day minutes. So as total day minutes increase, total day charge also increases linearly. That is what that 100% correlation means. All these circular graphs and everything, they are not correlated, right? So there is no specific pattern, as you can see, right? If I just zoom out this, so you see only four different lines, right? 1, 2, 3, and 4, and all of them belong to the four correlated features that we identify, right? So this confirms that these four pairs are highly correlated. What does that mean? We are going to get into that, but just like numerical features, there could be association between categorical features as well. You can think of, that maybe categorical features are correlated with each other as well. Let's check that whether that's the case or not. So here, if we look at this, we have there are three different categorical features. Being in a particular area code does not means whether you are going to have an international plan or you are going to have a voicemail plan or not, right? Similarly, having an international plan does not mean that you are going to have a voicemail plan, right? International plan, voicemail plan, 0% correlated or associated. You say that is what this means. So now once we have all this, what we basically saw is these four pairs are highly correlated, and we need to exclude, either we need to keep total day minutes or total day charge, total evening minutes or total evening charge. So basically one of the two for each of these pairs we need to keep. If you keep both of them, you are just keeping the same thing, 1, 2, 3, 4 and 2, 4, 6, 8. That is going to have multicollinearity because your model is going to be biased towards these columns, because essentially this is total day minutes, total day minutes, total evening minutes, total evening minutes. So you're basically supplying the same column twice. So your model is going to be very biased and you do not want that. So we are going to do this in the feature selection step of this process. Okay. Finally, in the exploratory data analysis, what we also need to see is whether there is a correlation between all of these various features with the target variable or churn. That means if having higher account length means you are going to have less churn or more churn. Think about it. If you are associated with a company for very long, maybe you are a loyal customer as compared to a person who just joined and they are seeing, oh, I don't find this useful, and they are going to churn. And are you able to identify patterns like this? That is why we do this part, that let's check the correlation of features with the churn variable or the target variable. Let me go ahead and run this. Let's see whether we are able to find the correlation of numerical features with churn or not. This is what we have, various numerical features, right? And with the churn, how do you read this? Let me just zoom in a bit. So here you have, let me just go to the very first one. So account length versus churn. On this axis, you have false. So people who did not churn versus people who churned. If you look at this, the line of people who churned is slightly more. It is not a very significant difference, right? You can just see with your eyes that it's almost same. So account length could be a factor, that maybe people who are churning are having higher account length as compared to people who are staying with the company. Similarly, if we look at number of voicemail messages, we don't see any pattern. But if we look at total day minutes, now this is very interesting. Total day minutes, you can see clear difference between the median total day minutes talk by people who are not churning versus who are. If we look at this total day charge, high charge, and we saw that day minutes and day charge are highly correlated, right? So if you are spending more, you are being charged more. Maybe customers are not ready to pay you that much. Maybe there are other competitors. So you see how this step is actually helping you form hypothesis that what could be good predictors of churn in this case. Similarly, if I, one interesting thing that we can see from this is the customer service calls part of it, right? So if I look at customer service part, so this is the customer service call. This is the median for people who are churning, and the median for this, you don't see a line because that line is here only, it's overlapped. So you see customer service calls, people who are churning are calling more, take support. And obviously, what does this mean? That means that these people are facing a lot of customer issues, and therefore they are calling more. So this could be a very good predictor of whether a person is going to churn or not. If, for example, you are a customer of a company and you are facing regular problems and you are calling that, hey, Netflix, hey, Amazon, I'm having these issues. A couple of times you call, 3 times, 4 times you call, and then you are like, okay, I have other options. These people don't listen to me. Let's switch, right? So you see how this step is actually helping you form stories that, yes, these are the things that I need to be careful about. Similarly, what you can do is we can see for the categorical features that leading to more churn. So now if you look at the area code, yes, you can say that 510, right? If I zoom in from 510, it seems like it is slightly more, but there is no big difference. So one of the hypotheses that you might be having that maybe since 50% of the people are coming from 415, maybe that is their primary market of this company and the network there is good. So they have the least amount of churn. Other ones are subsidiaries, and maybe that is why, but it is not a lot of difference. However, if you look at the international plan, right? So you see 42% and 11.5. So people who have international plan churn 4 times more as compared to who do not. What this could mean? That people who are taking international plan, obviously they are going to pay more, right? You need to pay more for an international plan, but the service might not be very good. And therefore, these people are fed up that I'm paying more and getting a very poor service. Let me just switch. Similarly, for people who have no voicemail plan, are churning more. This is what we have seen, that total day charge and customer service calls, evening charge, etc. could be good predictors of churn. Having international plan, 4 times more churn than not having, and having voicemail plan, half churn rate compared to not having, right? So these could be very good predictors that we need to keep an eye out for while building models. So you see why exploratory data analysis is very, very important and crucial step in this any machine learning project. Okay, moving on to feature engineering step. Now we saw that there are 3 different features who are not distributed normally. So we are going to transform them. Then we are going to perform train test split, then do a encoding of categorical features because machines cannot understand text, right? Machine can only understand zeros and ones or numbers. So we need to encode categorical features and then we scale them. Why do we do that? We are going to learn that. So firstly, of these three, what we are seeing is for number of voicemail messages, if I go ahead and plot this, this is what we had, right? Before transformation, this is what we currently have. So we have a lot of zeros and then a slight distribution around 30. This is what we saw. And obviously this is not a normal distribution. Here, what we are seeing is it is zero inflation. That is 72% of the values are zero and remaining 28% is being normally distributed around 30. There are multiple things that you can do. Either you can bin them, right? Or you can have that, okay, since many values are zero, so you can, break this column into two. Firstly, it will say whether this is zero or not zero, yes or no. If it is not zero, then what is the value of it? Or you can perform binning. I have gone with the first method. You can go with the second one as well. Like, it does not matter, but machine learning is the iterative process. So I try this. If this does not work, I try another method. So what I'm doing is I have created bins, 2 bins. Firstly, 0 to 20, because if you look at this, right, distribution 0 to 20, most of the values are 0. So this is like very low, and I have kept this as one of the buckets. that is number of voicemail messages is low, and more than 20, obviously number of voicemail messages are high. So I have just created two different bins, plotted the original distribution. I have created bins 0 to 21. Why I have written 21? Because this does not include the number here you have. So 0 to 20, if you want one bin, so you need to write 0 to 21 and then 21 to infinity. And then what we have created a new column called bin voicemail, and we plotted that currently. Okay. Now, once we have this, then for total international calls, we saw a right skew distribution. This is what we saw, right? Right skew distribution. So what we can do is whenever you have right skew distribution and you want to change it to normal distribution, there are multiple transformations that you can do. You can do logarithmic, a square root, box cos, and there are other various ways. Again, I am trying one of them, which is logarithmic, and it is not just simple log x, it is log 1 plus x. Why? Because log x, because total international calls could be 0. So log of 0 is undefined. So to take care of these kind of problems, I am doing log of 1 plus 0 because calls cannot be less than 0, right? There could be 0 or more calls. I'm doing log 1 plus x, that even if the international calls are 0, log 1 is 0, right? So the minimum value that can come out to be 0. And that is what I am doing. So created a new column called total international call log, that is logarithmic transformation, and perform the log 1 plus x of this column. Okay, and plot this. So now, yes, this might look very junky, but actually if you look at this, this is a normally distributed part, right? Or at least more normally distributed than the original one, and there is no skewness. So now we are done with the international calls pass as well. Similarly, for customer service calls, we saw that most of the values were between 0 and 2. And if I go ahead and plot this, this is how they look like. You see, again, this is a very high right skew distribution at 0, 1 and 2, right? So 0, 1, 2 and high right skew. Again, if you want to change them, you can either apply transformations, either you can do binning, etc. I have mostly gone ahead that most of the values are between 0 and 2. So I'm saying that customer service calls are low, medium and high, because this is also helpful for you to make suggestions to the stakeholders that yes, if the person is very sporadic and very rarely calling to for customer support, we can say all features considered, the probability of them churning is very low as compared to people who are very high, right? So this is what we did. Run this. Let's look at bin customer service calls and bin service calls. So you see, 1 is classified as low, 2 is classified as low, 3 is medium, and so on. Okay, this was just to check. But now, since we converted number of voicemail messages, total international calls, and customer service calls, what we can do is we don't require them, right? Because we have already converted them and now they are either categorical or normally distributed, and therefore we can drop the original ones. Let me go ahead and run this. Now here we have three new created columns: bin voicemail, total international calls, and bin customer service calls. Both of them are categorical in nature, and international calls log is float. Sometimes in feature engineering, what we can do is we can even create new column. For example, based on your domain knowledge, etc., you think that okay, we know that total day charge and total day minutes, evening charge, evening minutes, and so on, all of them are highly correlated, and we need to keep only one of them, right? For each from each pair. But what if total charge per minute call, right? So charge is per minute, right? So total charge per minute is high in the morning as compared to evening, as compared to night, as compared to international, and that is what is leading people to churn, right? So you can, based on any of the features that you want, you can think of, right? Maybe you have domain knowledge, maybe someone told you that okay, you might try these things, maybe that is industry standard, right? So based on all that, you can try to make new columns as well. I have just shown examples of 4, but this is what you can do. That, hey, can I do this? Let me run this. So that is going to create 4 different new columns: total day charge per minute, evening charge, night charge, international charge per minute. So you have all this. Okay. Now, remember, we learned about in the introduction part that we need to perform train test split first and then try to encode or scale. Why do we do this? The main reason is avoiding data leakage. And I'm going to show you an example. So basically what you're doing, especially in the scaling process, is that if you're not doing the train test split, for every column, you are going to have entire data set worth of data. And then when you scale, what you do, you try to find mean, median, standard deviation, etc. of the entire data. So you see, if you are doing that on the entire data set, in a way, what you are doing is you are looking at the those part which are going to go in the test dataset as well. This is what I have written here, right? What is supposed to be unseen during training, scaling before splitting violates the principle by allowing the model to see some information of the test set indirectly, right? So you are indirectly seeing the test set. That is why what you should do is firstly split the data and then you scale them. And scaling should be done on the training data itself. So you learn the mean and deviation, etc. from the training data, and then you apply the same on the test data. You don't need to calculate the same thing for test data separately. You learn the mean and deviation from the training data and apply that on the test data, right? That is the correct way of doing this. Let me show you an example. So firstly, we are going to do scaling and then splitting, which is the wrong way. Let's take two of the columns, total day minutes and total day calls, and let me run this, right? So this is what we have. Let me apply robust scaler to these columns and let's see what do we get. So here, what we have is, so this one, right? So 265.1 was scaled to 1.17, and similarly total day calls 110 was scaled to 0.3333. Okay, this is when you are looking at the entire data set, right? And then what if you do the opposite? Firstly, you do the split and then you scale. So you are storing the data frame, these two columns in split then scale. Let's split the data, right? Split that scale into 80-20 splitting, and then you perform the scaling part, right? Let me just do this. So you scaled only the test part, right? X train, and then you need whatever you learn from the X train, you are going to use on the X test. See one thing, or did you notice something? Here, what you're doing is scalar dot fit transform. That means you fit on the training data set and then you transform the data, right? So basically your scalar is fitting on these values. Then it is learning that, okay, for total day minutes, this is the mean, this is the median, this is the standard deviation. Similarly, for total day calls, it is learning that. And then using that, it is transforming that, okay, 265.1 can be scaled down to whatever, 1.17 or so on. Similarly for this, right? So that is what this fit and transform means. However, scalar has, after fitting on the X train, it has already learned the mean and transformation. So you do not need to fit this again on the test set. You need to use that learning from the training set to transform the X test. That is why you use dot transform on X test and fit transform on train. So for index 438, what you have here is, this is the value of total day minutes and total day calls from split then scale, which is the correct one. Now in scale.split, whatever we had, if you look at this, this is 0.3356, where here you have 0.33, and similarly you have minus 0.296 where you have 0.307. So you see, if you are scaling before and then splitting, actually your values are going to be different as compared to if you split first and then scale. So you see, that is why you are basically, if you are not splitting first, you are doing the scaling first, you are basically seeing the unseen data. That is the reason why you need to make sure that this difference does not exist. So once we learned that, so we were currently at, we created the new columns. Before doing any scaling, etc., we are going to perform the train test split. So let's do that. We have the data frame. The target variable is churn. So everything except target variable becomes your set X. You do a 80-20 split, and we are going to use random strain 42. It is used just so that we have repeatable results, because I need to show you here, right? If you want, you don't need to have this. And stratify. What does this stratify mean is, we saw that 85% of people have not churned as compared to 15% who have churned. So when we are doing that split in train test, we should keep that ratio, right? Because if you don't stratify, it is possible that all the 15% go in the test set, or all the 15% come in the training set. So that is why you are going to use stratify, that that ratio is maintained. You see, that is what we do. So we do the train test split, and if we look at the size of them, and now once we have this training and test split, then what we need is we can go ahead with the encoding as well as the scaling part. So encoding is basically used. So there are various ways or various things that you can do here. Firstly, let's look at which of them are categorical variables, because categorical variables are the only one that require different types of encoding. As we learned that machine learning models cannot understand text, right? So if I learn this, these are 1, 2, 3, 4, 5, and 6 different columns that are categorical currently. Churn is basically, true or false, as we saw Boolean values. So we are basically going to map them as true, 1 for true and 0 for false. So let's run this. So that is what it is going to have. Okay, not a big deal. But similarly, for international plan and voicemail plan, we have no and yeses, right? So we can just simply go ahead and do direct mapping that, hey, no means 0, yes means once. So that is easier, right? So this part is easy. Similarly, we can do that for voicemail plan as well. Okay, so if we look at voicemail plan, so you have 1010 area code. Another type of encoding that we can do is called frequency encoding. What is frequency encoding? Firstly, let's look at, since we already saw in the graph, right? The graph that we saw, if I go back to this part, correlation of features with target variables. So here we already saw that the churn percentage of various area codes is not that of a big deal, right? So if I come back to this part, frequency encoding, I will do the same, and I'm going to see the same, that hey, the churn rate of coming from various area code does not provide any drastic information that hey, coming from one particular area code means you are twice or thrice more likely to churn. Because if that's the case, we should do target encoding and not frequency encoding. But if we look at the frequency of them in being in the training set, we see that 415 comes 50% of the time, whereas the remaining two comes 25% each. So since there is no clear relationship to the target, that is churn, right? Almost similar for every area code. What we can do is we can simply do and that hey, if it is 415, apply this value. So it helps us to maintain that, okay, coming from 415 means higher proportion. Machine learns that. So that is what we are doing, is we are making a variable frequency encoding area code. We are doing the value counts normalized to basically this part, right? And then we are going to map that on the training as well as the test part. So if I go ahead and run this, so 0.50, so basically this was 415, then these ones, right? So you have area code encoded. Now, if we look at the state part, 51 different states. Let me go ahead and run this. Let's see if we can find whether there is a relation to the target. So you see, California, Maryland, New Jersey, South Carolina, Michigan, very high churn rates, like coming from these 22, 28, 26%. However, if I look at another ones, right? Illinois, 10%, right? Wisconsin, 7.5%, Arizona, 7%, Virginia, 6.8%. So you see, there is clear difference that if you come from certain state, your possibility of churning is very high as compared to others. So in these kind of cases, doing target encoding is a very good way. So we can do the same thing here, that yes, we target encoding state, we did the churn rate of each of the states, and we map them to the state column for both training and test set. So if I go ahead and run this, it is going to have that, okay, this is what the encoding looks like. So you see the difference between when to use frequency encoding, when to use target encoding, etc. Also, remember, state is a categorical column with high cardinality. Then again, this is a very, very highly asked question in interviews. If you have a categorical column with high cardinality, what should you do? Here you had 51 unique values. You cannot have 51 different columns saying that, okay, whether California, yes or no, whether Maryland, yes or no, because it again curse of dimensionality, right? So there are various ways that you can do. One of the things that I handled here was target encoding, but what you can do is you can do frequency encoding, you can do hashing encoding, you can do one hot encoding, but with a threshold, not in the top 5 states, then everything else is a other state, right? Similarly, here what you can do is you can say that all others where you have 20% or more churn rate, they become columns and everything else become other states. So yeah, you can try all these kind of stuffs. Once we are done with similarly, we can do and see whether we have binned voicemail, and for various bins that we created, low and high, what are the churn rates. So you have, if you have low voicemails, your churn rate is 16% or higher, so almost double, right? And why this could be, again, we discussed about that there could be less engagement, technological issues with the voicemail, maybe people prefer alternate communication channels, etc. So you see, all this gives you hypothesis, stories to tell. Again, since there is a relationship, what we do is we can go ahead and do target encoding. Again, run this. We did the target encoding part. And if we look at bin voicemail, or where do we have that? You have that, right? So that is encoded here. Now you have binned customer service calls. Again, if I go ahead and do this, almost 5 times more churn rate as compared to other people, right? So which is very high. Again, do the target encoding in this case as well, right? So now once we are done with all the target encoding parts, right, let's look at whether there is any column that is left. Is a good way of doing that. Let's just run info that, hey, is there any categorical column that is left? No, right? Everything is either integer or float. So all the encoding part has been done. Now we are going to perform scaling. Now we saw there are outliers, right? So we need to use scaling methods which are not dependent upon outliers. One of them is robust scaler. If you use standard scaler, etc., they are based on mean and standard deviation, and you always know mean is always sensitive to outliers. So that is why we are going to use robust scalars in this case, because it is going to use median, which is insensitive of outliers. Now, what we are doing here is, you see, exclude columns. Why are we excluding these columns is because we already encoded them, right? State, area code, international plan, etc. And if you look at this data, it is already scaled, but you need to scale these ones, right? You have 0.15 as state, but 106 at account length. So why do you need scaling? Because you see, the range of account length, total day minute, the total international charge is completely different. This will be highly maybe 0 to 10, whereas this could be like what, 80 to 200. So your ML model does not know whether this is account length or this is total day minutes, etc. All they are seeing is numbers, and if they're saying, okay, oh, this is very high number, maybe that is a very good predictor of churn, right? So you see, that is going to introduce bias in your model. We don't want your model to have biases in there. So that is why what we do is we need to scale every feature to the same range or similar range, so that now what the model is going to learn is actually pattern and not biases, right? So that is the reason of performing scaling, right? So we do scaling numerical features. We exclude these columns because they are already in the range that we want. So the remaining columns are the columns that we need to scale. Let's apply the same thing again. Fit transform on the train, and then whatever you learn from the training, you just transform based on that on the test. Let me go ahead and run this. So that is what we get. So everything is transformed here, right? Account length is transformed, total day minutes, etc., based on various different things that were learned from the training set. Okay, so now once we have this, then at this point, our data ready to go into a machine learning model. But here, what do we have? We have 23 different columns, right? Now, we saw when we were looking at correlations, etc., there are columns like total day minutes and total day charge, which are 100% correlated, right? And you can see from these scaled values as well, right? So this was, you see how the robust scaler was, it learns the mean and standard deviation of every column separately. But when this is applying the transformation, you see they are very close to each other. So what does this mean? This means that they are correlated and giving you the very same thing, right? So you do not want that. So what we need is, firstly, let's remove the highly correlated features. Again, doing the same thing, Pearson correlation matrix here, and you have the same pattern here. Total day charge and total day minutes, etc., is one and highly correlated. But there is another one that has popped up. That is wind voicemail, that the voicemail column that we created and voicemail plan are 92% correlated, right? So we need to keep that in mind as well. So this is something that has been because of our feature engineering step. And there are various ways of doing that, right? Maybe you know that total day minutes could be a better predictor as compared to total day charge based on your domain knowledge, etc., right? So there are some of the things that I have already mentioned here. Empirical ways of doing is using feature importance from tree based models, etc., right? Maybe you are considering, okay, which one has the lowest variability, because if there is something, for example, there is a column whose value is 1 1.0.99, mostly along this lines. So you can just say that, okay, this column almost remains constant for every value. Is it giving you more information? No. But some column which has high variation, it can be 1, it can be 5, it can be -2, it can be whatever it wants, right? Now that is something that is giving you information that yes, being 5 means something, being -2 means something, right? So we can look at the variation part, and if there are two where one of them have more variation, keep that. So that is what this means. So what we are going to do is, let's apply this thing, right? Let's apply the feature importance from the tree based model. So let's use random forest classifier, train them, and see based on the importance part which all features are important. So here, if you look at this, so total day charge, total day minutes, almost similar. Customer service calls, obviously this is very high. And remember, how does this all tie back to our EDA? We looked at and see that if I go to EDA part, right? Let me just go ahead and I look at correlation of customer service calls. So if I look at this, and I was talking about this, that hey, customer service calls, right? Here we have that people who are churning are calling a lot more as compared to people who are not. So you see how this ties back, that customer service call or binned customer service call features as one of the topmost predictors of churn. So you see how your EDA and your various other steps in machine learning models are correlated with each other. So that is why never ignore EDA, right? So now based on this, if you look at this, area code is like the least important. And we saw that again from EDA. All of the various area codes have very, very similar, and there is no significant difference between the churn rate. Wind voicemail, however, is a curious factor that we did this, but it is one of the very least again feature to predict churn. Very important, right? Now let's look at the variance part, right? Let's apply this one, right? So the redundancy consideration variability part, that hey, if we look at the variance and this is sorted by highest to lowest, if we look at these four columns that we created, e to the power -7, e to the power very, very low, right? It means that the charges per minute remain same for international day, night, and evening as well, right? So we can drop these because it is almost like being 0.91, 1.1, 0.91, 1.1. No new information. As compared to binned voicemail and voicemail, which one should you drop? Binned voicemail. Out of binned voicemail and voicemail plan, we should keep voicemail. Let's drop all this. And then if we look at instead of total day charge and total day minutes, which one should you drop? You can drop the charges, right? Total day charge you can drop, total day evening charge you can drop, because minutes are usually higher variability as compared to the charges. Similarly from this, right? So let's do that. So that is what we are going to do. We are going to, drop all these columns, right, that we saw. And that is what we are doing in feature selection. That, hey, based on our analysis, these are the features that are not very good predictors of churn. And therefore, we are going to drop them from both training and test set. So if I go ahead and run this is what we have. That now you do not have all those columns, total day charge per minute, etc. Right? So now you are left with certain number of columns. Okay, now these could be good predictors of churn. Okay. Now remember, there is still one of the problems that is remaining. That is, we saw that 85% have not churned and 15% only churn. So if you don't do this part, right, balance the classes, you directly go to model training, what will happen is that your model, because 85% of the data is majority class that is not churning, it is going to overfit to that, and that is going to lead to error. Why? Because most of the data learned by the model is about not churning, so it will do a lot of error when it needs to predict churn, right? So that is why what you do is you do the balancing of the class. Now balancing can be done oversampling, undersampling, etc. What does overslamping and underslamping mean? Let me go back to this part and tell you. Okay, if I go to the class balance thing, here we have about two, whatever, right, these many, let's say for the sake of simplicity, 2700 no churn and 500 churn. So what is oversampling is that you keep the majority class at is this 2700, and from this what you do is you increase them to 2700 so that in your data you have similar proportion of not churning and churning. Or what you can do is you can do undersampling. What is undersampling? You keep the minority class as it is 500, but out of this 2700, select any 500. So both of them become 500. So you say what is oversampling, what is undersampling, and both have their uses. What we are going to do is we are going to use the oversampling, right? But then oversampling can also be done in various ways. You might have learned about SMOT. SMOT is something which is called synthetic minority oversampling technique. But there is a problem which is solved by adaptive synthetic sampling. What is happening is, if you think about it, churning and not churning are two different classes. What SMOT does is it just takes one example from the churning part or the minority class and just creates an artificial value around it. However, ADASYN or adaptive synthetic sampling, what it does is it looks at the local distribution of the class. That means if there are two values, right, two values which are very close in other features, that is, it could be non-churn or churned, then those difficult decisions, right, it generates more of that. What will that do? For example, think of a cricket match happening between, let's say, India and Bangladesh. In India, what are the maximum number of fans going to be? Indians. Now let's say most of the Indians are sitting at one corner and a lot of Bangladeshis are sitting in another corner, right? So what SMOT will do is, since Bangladeshis are the minority class here, this is person number A around that same, Bangladesh class, and it's easier for us to identify or differentiate that, okay, this new person who is sitting very close to the Bangladeshi side would be predicted as a Bangladeshi fan. However, think of those scenarios where Indians and Bangladeshis both are mixed together in, let's say, a third part of the stadium. Now that is difficult to differentiate just by looking at it whether a person X is Bangladeshi fan or Indian fan. Like if they do, if like you remove all the flags and all the colors on their face, etc. Just by looking at it, right? So what does adaptive synthetic is? It generates new values in those third regions of that stadium where it is difficult to make predictions, because then models can learn how to separate them, right? That is the entire story in classification. You need to separate the non-churn with the churn, or class A with class B. So you see how adaptive synthetic sampling is better than SMOT. That is why you should use ADASYN and compared to SMOT. And there are even better methods than ADASYN, but for this video let's stick to that. Okay, so that is what we are going to do is, again, before the balancing we plot them, and then after, sampling strategy minority, that you only sample the minority class and plot it. After sampling, let me just run this. Let's see what do we get. So now, before this you had this distribution highly imbalanced, and then you simply oversample the minority class and you have almost similar, right? So you have before and after picture. So now the dataset is balanced, everything is encoded, scaled, etc. We have training set, test set, etc. So now we are ready to train our models. Before training our model, there are some things that we should go through. In a churn dataset or a classification or basically a binary classification, what is positive class? Churn. Basically, to churn is a positive class and non-churn is negative class. Why I'm doing this is because we need to learn about these various metrics: accuracy, precision, recall, F1 score, and ROC AUC. And here, if you see accuracy, what does accuracy mean? How many customers were correctly predicted? So if the model is saying this is person is going to churn and they churn, if the model says this person is not going to churn and they do not going to churn, that means true positive, that means saying to churn and churn, true negative, saying not to churn and did not churn, divided by the total. So true positive plus true negative plus false positive. What is false positive? The model says churn, right? Model is saying to churn, but in reality that customer did not churn. So false positive. False negative, model says it will not churn, the customer won't churn, but the customer actually churned or left. So you see, that is false negative. That is what is accuracy. What is precision? Out of all the customers predicted to churn, how many actually churned? How do we get the total number of customers predicted to churn? Some of them are going to be true positives. Model is going to say churn and the customer is going to churn. Some of them, model is going to churn, but they are not going to churn. What is that? False positive. So true positive divided by true positive plus false positive is the precision. So model is saying to churn and how many of them actually churn. That is going to say tell you how precise your model is. Recall is out of all the total customers who are churning, how many your model was able to correctly predict. Your model is going to say not churn, but actually they are going to churn. So that plus true positive, that is model that predicted to churn. So that is going to be the total number of people who churn, and true positive is basically the number of customers predicted by the model, right? So out of the customers who churned, how many were correctly predicted? So you are recalling something, right? So it's recall. Both of them has different advantages, right? And we will learn about this. But what about F1 score? F1 score is basically when you try to balance both of this, that you are not sure whether precision should be important or recall should be important, then you use F1 score. And ROC AOC is basically a variable or a value that actually tells you how good your model is in separating the classes. Model has learned to say this person is going to churn versus this person is not going to churn. So model learns to differentiate that. That is what this area under the curve. Now let's look at some scenarios where precision could be important and when recall could be important. For example, when could precision be important? Think of it. What is precision? Again, let's go back to the definition. Out of customers predicted to churn, how many actually churn? If the model is saying 10 people are going to churn and all those 10 people actually churn, model is 100% precise. However, when the model is saying these 10 people are going to churn and only 8 people are going to churn, the precision is 80%. But model said two more people, those two people, let's say our policy is that if we know that this person is going to leave my company, I may give them discounts, offers, etc. Right? Now, those two people, model said are going to leave. We are going to give them discounts, but they were not actually going to leave. So actually, you are wasting money. So you need, if you want to avoid incorrectly predicting that a customer will churn when they know they won't, then that is why when precision becomes important, that means your model is becoming conservative. So what does this mean is your model is only going to say this person is churn when it is highly confident that the customer is actually going to churn. And this could be important, right? Because for me, if I'm not going to churn and model is predicting me that this person is going to churn, then it is possible that I'm going to get those emails and I get frustrated that, hey, I don't want to look at all these. Or maybe for the companies, it is expensive, right? They are going to waste their resources on people who are not going to leave the company, but the model is saying that yes, this person is going to leave the company. Just the reverse case is recall. We don't want, or we want to minimize the people who are leaving this company. So maybe what they are eyeing is long term value from a customer. For example, I am a customer. If I remain associated with the company for 2 years, I am going to bring in more value as compared to the discount the company is going to give me to keep me for let's say next 3 months, etc. Right? So in those cases, recall is important. Even if a customer is not truly at risk, the model is going to identify at risk and they are going to spend that money, that discounts, that promotions, but to them, keeping customers is more important. You can think of small startups where recall could be very important. If you are just a startup, you are going to acquire new customers. Having that stagnant customer base is very important to you, right? So that is why you are going to give more promotions, more you, right? So there, when you are developing models, recall could be a very good factor or very important factor. So see, when can one overpower the other? Now, let's do various models. So there are about like 8 or 9 different models, and since this is a classification problem, so we are going to use the basics: logistic regression, naive bias, light GBM, right? The advanced ones as well as the basic ones, medium ones, etc. These are the various models that we are going to have. And then what we are doing is we are doing cross validation. Another question very important asked in interviews are, what is cross validation? So basically what you do is, right now what you have is the training set and test set. Test set is kept aside. You are not doing anything on test. You have the training set. When you say five-fold cross validation, you divide the entire training set into 5 splits. Let's say split 1, split 2, split 3, split 4, and split 5. In round 1, what you do is you fit the model or train the model on split 1, 2, 3, 4 and predict on 5. Then in round 2, what you do is you train on 1, 2, 3, 5 and then predict on 4. Similarly, you do for all them. And then you calculate the various metrics, for example, accuracy, precision, etc., on the splits that you are not training and calculate the average. What does this do? It helps you make sure that your model is stable, because for five-fold cross validation you are doing the same thing five times and taking the average of the metric. So then you can be pretty confident to say that yes, if I am saying 80% accurate, yes, this has been done 5 times and on average it was 80% accurate in all of them. So that is why we do cross validation. So see, what is cross validate? That within the training set you divide it into various chunks. You can do threefold cross validation, you can do fivefold, etc., depends. And then these are the various metrics: accuracy, precision, recall, F1 score, and ROC AUC. And then we are going to calculate various metrics on the cross validation set and then on the test set, so that we know that okay, this model is doing good in the cross validation part. That means this model is trained well, has learned the parameters and learned the trends accurately, and then is going a good job on predicting on unseen data as well. So that is what this does. So calculates various cross validation scores, then fits the model, predicts on the test set, and then do the evaluation metrics on the test set as well, and then basically gives you a comparison of cross validation set and the test set. Let me run this. Let this run for various models so that it's easier for us to see and see what this brings. As you can see, this has been trained, and if we look at the comparison part, let me just run this. Let's see what do we get. So you have various models and various matrices as columns: accuracy, precision, recall, F1 score, and ROC AUC. And you have accuracy on the cross validation set and test set. This is very important. Why? Because if there is a drastic difference between cross validation and the test, it means that there is overfitting. So here, if we look at the accuracy column, it seems that for all of the models, they are comparable. However, if you look at the precision part, so there is a drastic difference, right? Almost less than half precise logistic regression. So what does this mean is this model is overfitting on the training set. But if you look at other ones, right, similarly for support vector machines as well, almost half. So there should not be any drastic difference, because if there is drastic difference, then that means that it is overfitting on the training set, and we need to take another set of steps to actually avoid that. Similarly, look at k nearest neighbor, more than half. However, if you look at these ones, right, light GBM, XGBoost, quite comparable on the precision part, on the accuracy part, on the recall part as well. If you look at the F1 score, which is a balance between these two, again, quite comparable. And then if you look at the ROC AUC, basically how good the model is. So 87 or 88% of the time, this light GBM is able to differentiate between no churn and churn classes, right? So based on that is what we can do is, if we look at what is important to on most of the parameters, if we look at this, light GBM has the highest, right? So if you look at accuracy wise, so it is on the test set, it is highest. If you look at precision wise, highest. Recall wise, second highest, because logistic regression has highest. Then F1 score wise also, if you look at it's 0.75, so kind of highest. And then this one is also very good, right? Very good at distinction. So almost across all the metrics, light GBM is performing very, very good, right? So the best model for us is light GBM. Cool. Once we have decided the light GBM, this is doing the same thing again, but here what I want to show you is the confusing matrix and how to read it, because confusion matrix in something that is asked, again, one of the highly asked question in data science interviews. Let me just run this. Let's see what do we get. This is what a confusion matrix looks like. It is one of the most asked question in data science interviews, and let me tell you how to read a confusion matrix. So on the left side you see true label. That means what's whether the person actually churned or not. So 0 means did not churn and churned. And here what your light GBM model predicted, not churn and churn. So if you look at this one, right? So diagonal values. The model predicted to not churn and actually not churn 553 times. Very good. The model was correct. The model predicted to churn and the customer actually churned 69 times. So this is true, true negative. Why negative? Negative in churn is not churning. So predicted not to churn, did not churn, true negative, true positive. Then what is this 17? Model predicted to churn positive, but did not churn, false positive. Model predicted not to churn negative, actually churned, false negative. So you see, true negative, true positive, false, false negative. That is how you identify a confusion matrix. Once we identified, let's see whether can we do, whether we can improve this. Let's perform hyperparameter tuning for this light GBM, and there are various features. What you basically do is, right now what you used, what if you look at the light GBM model, right? So here if I go back to this model where we had light GBM, all we had was LGMC classifier. Verbose -1 is basically, it does not give you with like at what step of training this is at. So we are basically using default values of light GBM classifier. But maybe changing these various parameters can give us a better model. And that is what we are trying to see. So you have all these various factors, and because there are resources constrained, if you have a cluster or supercomputer, etc., you can try to train on all this. I've just included it for your convenience, but I'm just going to check for these three different parameters, and these are the different steps. Also, there are two ways of searching, two major ways. There are other hyperopt, etc., advanced methods as well. But just for the basics, randomized search and grid search. Random search, what it basically does is you specify a parameter and then randomly it picks a combination and looks for it. But in grid search, it is like looking at every point. Think of this in an example. Suppose there are thieves in a locality. So, what is random search doing is police is going knock on any random door and try to check whether there is a thief or not. Whereas grid search, what they are doing is every single house they are going to knock, open, and check. So obviously, the grid search method is going to take a lot of time, but you are going to 99% of the cases going to find the thief. But in random search, you need to be lucky, but you can cover very vast area. So both has advantages and disadvantages. Whenever you are starting to do a hyperparameter tuning, your idea should be to look at as big of a grid as possible, and always you start with randomized search. What we're doing is we are providing a hyperparameter space. And remember, this is again another question that was asked to me in one of the recent interviews, is that how do you initially decide the search space? So what did I do? I started with the very default, because these things are optimized and perform very well on their default values, right? So light GBM performed very good, right? If you look at this, performed very, very good. But we want to improve it, right? So the initial search space is default values, and then we try to make changes to that. So once we have that, we initialize the light GBM classifier, and then we are trying to do random search. And scoring parameter is where you, based on the business requirements, again, when is precision required, when is recall required. If you do not know which one of this required, so you should always go with F1, because it is a balance between precision and recall. Here we do not know. I'm going to score the models based on F1 score, so that is going to improve our F1 score. What was our F1 score here? We have 75%, right? And if I go ahead and run this, and let's see if we are able to find the best hyperparameters and if our model improved or not. Let me just run this. So here we found the best parameters, that yes, if your number of leaves are 40, number of estimators are 500, and learning rate is 0.05, right? So here in this case, number of estimators are 500, learning rate is 0.05, number of leaves are 40. That is the best parameter according to random search, right? Now based on that, what we did was, if we look at our recall or F1 score did increase slightly, right? 0.76. Precision also increased from 0.80 to 0.87, but recall dropped. ROC AUC is also very good. What happened here is, if you look at this now, initially you had 553 here. Here initially you had about 69, I guess. Let me just check. Yeah, 69. So it went down a little, right? It is 65 now, but good amount of increase in the, when the model is saying not churn, they are not churning, right? If we look at this one, right, false positive, the model is going to say churn, person did not churn. What do we have initially? We had 17, so like almost half, right? So you see, now the model is very good at of predicting churn. Why? Because this is wrong only 9 times when the model says it is going to churn, but it is not churning. So you see, very good. So it has improved our model. And this ROC curve, this is what ROC AUC curve looks like. This line, how to rate this is, this line is called line of random guess. So if you just say 50% of the time fraud, 50% of time not fraud, or 50% time of the churn, 50 not. So this is what you are going to get. But ROC AUC, that is area under this curve, is 90 or 90%. That means that 90% of the time this model is able to distinct between non-churn and churn classes. So this is a very good model. If you want, you can start tuning other parameters as well, based on what do you require. Do you require precision more, recall more, F1 score more, whatever, accuracy more? But in classification models, accuracy is not always the best metric, remember that. So yeah, let's suppose this is our best model that we have. Then why did we do all that? Because we need to make predictions on the new set. So the first step is, you need to store that model. So what we are doing is, we are pickleizing the model. Basically, whatever model has learned, we are saving that into a file so that that file can directly be used to predict. You don't have to retrain the model again and again on the training set. The model has learned everything and then we can directly use it. So that is why we save the model. Then let me run this. So this model has been saved as .pkl file. Now, what we are going to do is develop a ML pipeline. If we have to summarize this entire thing, and what we actually did was, this is in summary, this is what we have done, right? We corrected the data type of area code column. We dropped the phone number column. We binned this column into two bins, applied transformation, etc., etc., and finally used the best light GBM model to make the prediction. So these are the 11 things that we did. Even if you want to make this even more concise, if we have any new data, this is what it should pass, right? Because new data is going to be in the raw format. What we did was we made a lot of encoding, changes, binning, log transformations, etc. Right? So that is where ML pipelines come handy. That hey, you do not have to do this again and again. You can develop an ML pipeline and it will pass the news dataset through that pipeline and finally predict. In short, these are the 5 or 6 things that needs to be done. This is what we need to do and our pipeline should have all these steps. Okay. But before going there, one thing that you need to keep in mind, very important, that there are some transformers. What is basically ML pipeline doing? It is transforming the new data into a required format that you want so that the saved model can make predictions. Because saved model has learned something, right? If the new data is not in the format that the model wants, it is not going to able to predict. So we need to change that. So there are some transformers called column transformers and other estimators that need to be fitted to the training data before you can use them for transforming new data. Again, fitting computes the mean and standard deviation for scaling. And if you don't do this, you are going to get not fitted error. We are going to see this, and there are some ones which do not need to be fitted. So let's look at this in action. So you have the encoding state, encoding area code, and these are the variables that we created. Basically, target encoding state, these are the variables that we have from the encoding part. Let me just go back, right? If we look at target encoding state, right? If I go to this, you can see that target encoding state is a variable here, right? So that is what we have, and we have developed a encoding function. So what we are basically doing in this is you take the international plan column. If it is no, 0. If yes, 1. Similarly with voicemail plan. For state, we are doing the mapping with encoding state, that for California it was 28% churn rate, etc. Similarly for area code. And then for customer service calls, what we are doing is we are creating low, medium, and high bins and then mapping based on the various bins, right? The churn rates. Once we have this, then we are also defining another function where we are applying the log 1 plus x transformation to the total international calls. Cool. Then we also need to drop columns, right? Remember this. We need to drop columns that are not important. And we did not use for training our model. So we did not use phone number, number of voice messages. We looked at international minutes. These were highly correlated ones, right? So we do not need these columns. So obviously the remaining columns are the ones that we need to scale. So these are the columns that we scaled. Now this is where we are creating the pipeline. So basically what we're doing is the first step is encoding. Encode is basically function transformer use the encode function. What is the encode function? This is the name of the step, right? Do not confuse this with anything else. This is the name of the step. So step 1 is encoding. And how are you going to encode? You are going to encode using function transformer. Function transformer encode function is this one. That means firstly you encode all 1, 2, 3, 4, and 5 columns. Then what you are going to do is step 2 is log transform using this. So transform this column, total international calls and save this into total underscore international underscore calls underscore log. Once we have this, then you drop the columns, so drop all these columns. And then what you are doing is you scale the remaining columns, right? What does this remainder pass through main is basically scale these columns, and the remaining columns you pass through as it is in the correct format. As we learned that function transformer does not need to be fitted on anything, right? Because why do you need to fit this, right? All you need to do in this case is 0101, right? And you have already values in the encoding state, encoding area code, right? Similarly encoded bin CSC. So you don't need to fit on anything. But however, remember, robust scaler, you are scaling something. To scale something, you need to learn from the data. That data needs to be provided. So you see, I said that we are making a copy of df, right? If I go back to the load the dataset part, here I had df copy, right? That is the reason what we are doing is, so basically the entire thing that we did until saving the best model, we are just doing this in this one single cell, that hey, take the x and y's, do the train test split, and then you fit on the train data, right? So this entire thing is going to fit. So basically this robust scaler is going to learn from the x train part of it, right? It is going to learn from x train part. Why? Because train data is x train copy. Then once you have done all this pre-processing, then comes the part of predicting, right? So we have written, okay, this is the best model we have loaded. So this is the model that we stored, we loaded it. And then what we are doing is we are writing another function called predict churn. And what we are doing is the transform data is stored. So basically this pipeline is fitted on the training data and then it is transformed. So when you do transform new data, these columns, right? These columns are transformed using robust scaler. Everything else remainder is passed through because all other columns have either been encoded, locked, transformed, or dropped, right? And then we are basically, this is just for, visualization purposes. We are doing this to have this in a particular order. And finally, what we are doing is once you have the entire transform data frame from this pipeline, you are going to make prediction out of it and you return the prediction. So let's run this part, right? Let's run these functions, and then let's also run this function. So this is the pipeline that has been created. You have first one as encoder, lock, transform, drop columns, then you scale the robust scaler and remainder columns are passed through. So the entire data is passed through this whenever you have a new data, and then using the prediction function we are going to predict. So for example, here I have 10 different customers with various values in the state, phone number, account length, etc., right? So this is how the data is coming. What I'm going to do is I'm going to run, right, and see if I going to run this, it is going to tell me which customer is going to churn and which is not. So you see, customer 1, 2, 3, 4 is expected to churn, 5, 7, 9, and 10 are not churning, etc. What you are doing is you have given a new data, how fast it is that this entire data, right? So this entire data, what happened to this data is this entire data went through this pipeline, that firstly it was encoded. What all was encoded? These columns. Then this column was transformed, these columns were dropped, these columns were scaled based on the learning from the training data. So once we have trained it, we don't need to train them again and again, right? So the pre-processing pipeline already learns that. And then based on that, transformed data, right? So you have the transformed data, you are going to predict. So you see, don't need to retrain your model again and again. Just as a new data comes, you predict. For example, let's say from Ohio, I change this to California again, right? California, this is, I'm just, just demonstrating you. Run this again. So this is another examples. And basically a new customer has come. And if I'm going to, and that was customer number 1. If I'm going to run this again, so you see, this has so fast predicted again that customer is predicted to churn. So you see, that is how we do this end to end. So what we did till entire thing here is, so that is how make machine learning pipelines in production, that until this step hyperparameter tuning, right, you do all the steps, right, you try to make your model as good as possible based on the business case. Once your model, you are satisfied that yes, my model is very good and it is having a good amount of accuracy or precision, etc., then what you basically do is you can save the model into a pipeline. So this is a trained model. Best LGB model is a trained model. Then you can make a pipeline so that whenever a new data comes in, it is passed through the entire pipeline in one single go, right? So it passed through the entire pipeline in one single go and it is transformed, right? And then finally you can directly predict on the new data. I hope this was useful for you. This is how we develop models for production. I hope you are feeling confident enough that you can take any project from start to finish, develop production quality models and deploy them as well. I'm going to share this entire notebook in the same. So you see, I have added this here, Sony Research IPython notebook. If you click on it, you can see the entire thing here. So don't need to worry. I hope this will be helpful for you. You have the entire thing here, right? So yeah, this is how we do it. I hope this video was useful. Let me know if you want to see any changes to this or you have any other data sets that you want me to take and go through this entire steps again. I will see you guys in the next video.